except when you use PHP the right way. Anyway. All right. Switch of gears, complete switch of gears. We are starting to talk about naming, right? I already gave some hints in the other lectures that naming might be something very important, right? So, I mean, first of all, what's this naming story all about? It's all about associating some sort of English-like things to things that otherwise want to be binary. Right? So, I mean, this is a problem that's as old as programming computers. And I mean, to some extent, it existed in mathematics, but in mathematics, things are abstracted away anyway, and those people got used to basically just writing formulas and calling those formulas the name that it's not maybe as crucial and as important. But obviously, whenever things get low enough, close enough to the transistors, they have to be bits. We don't have any, I mean, base 3, base 4, or any other base. It's base 2, so it's bits. It's zeros and ones. And zeros and ones are not something that people are comfortable with. And I give you an example. Even if it's not exactly zeros and ones, but it gets close enough, IP addresses, very few people know their IP address. Why? Because it's very hard to memorize. Now, we put up with memorizing phone numbers, and that seems to be an effort big enough. Not even anymore, right? So how do we deal with phone numbers now? Well, we ask the phone, and we put a nice contact, right? We ask the phone to say, you deal with it. I mean, my kid has a new cell phone and has an older cell phone. Both are numbers I don't know, but my phone does. Right? I have a nice directory, right? So in effect, it's a form of naming. I associate, but locally. I associated the name with something that had an ugly name before. Okay? Now, why do we have phone numbers and not names? Because it's much easier to implement numbers with lower level technology, and the phone technology is old. It's 100+ years old. Right? So it was crucial for the phone technology to, in fact, use numbers and not anything else. Right? Now, even before I go into naming for distributed systems, I want you to understand that naming is a general problem in computer science. I mean computers, not computer science, using computers. Right? For example, I would like to point out some things about programming languages, where you, in fact, have a big naming problem. Okay? So naming, it's all about nice name versus something more weird. Okay, so let's dig into some programming languages and figure out just how useful these names are and what could we use instead of a name. Now, another notion related to name, and I want to put it side by side, is the notion of identifier. Okay, so what's the difference really between a name and an identifier? Well, we kind of feel that the identifier has to be stronger. So identifier has to be something that looks more unique. It pins it down precisely. Name can be something relatively loose, and in particular, you can use aliasing for names, possibly, but not necessarily for identifiers. So in fact, identifiers are some sort of names that have stronger guarantees, are cleaned up, at least according to some people. I mean, at some point, you still have to declare something to be stronger, right? And we declare these identifiers to be stronger. So this could be a possible definition, right? So an identifier refers to at most one entity. Each entity is referred to by at most one identifier. So there is this paired one-to-one relationship. And an identifier always refers to the same entity. It turns out to be extremely important because that means the life of the name, the identifier, is as big as the life of the object. And because you cannot really reuse them, the identifier could live even much longer than the object. Right? The object could get created, destroyed, or switch from in-memory, on disk, or whatever. Right? But the identifier is supposed to live forever. Now, it's hard to get these identifiers. I mentioned a number of lectures back about the UUIDs, the universal identifiers. Okay? That's an attempt to generate these identifiers that have strong uniqueness guarantees. Right? So in some sense, it's not quite a reservation system and so on. All kinds of trickery it's used, including random number generation, right? To form these identifiers, but once you form one, you can associate it with a certain resource that you have, and then that's going to be your unique ID. Now, obviously, you don't want to use that UUID. It's really big and really ugly, right? What you want to do is then put aliasing on top of it to make it humanly readable. But identifier, it's at a lower level. So let me ask you, I mean, let's go through some questions about particular programming languages and see what could potentially be an identifier. Okay? And because when you're taught these programming languages, these ideas are not articulated, you might not even have realized that that's the case. So for example, in, let's say C, C++, so I have an object. I mean, that can be a variable, that can be anything you want. What's the identifier? So what's that thing that makes the object unique? Or what's almost an identifier? Or when the identifier in C with respect to this?
I would suppose maybe, well, the name that you give the object would be alias, so it's not bad. It's not very
Well, so this is what I'm saying. It's not pointed out when you're taught C and C++. It turns out that C is close to assembly, and in assembly and in C, the address in memory is really the identifier. Okay? So you can tell that two objects are the same only if they have the same address, and that's it, and there is no other way. Okay? This, in fact, can produce a very deep test. Are these two objects the same? A lot of languages support, for example, some very special form of equal. Because the identifier and the naming and, on the other side, the content are related to when do you declare two things to be the same. So if a resource, if an object has an identifier, you can essentially say two objects are the same if they have the same identifier. And if the identifier is unique, that means, right? So if you allow aliasing, when you resolve the aliasing, if you get the same identifier, then the objects are really the same object. That's different than equal, right? A lot of the frustration related to programming languages, for example, comes from the fact that you have all kinds of equals and you don't realize what the difference between them is. Most of the time, the normal equal, it's in fact not are they the same object, but do they have the same value, or can the values be coerced to the same value? For example, JavaScript is notorious for this. The string that contains the number 1 will be equal to the number 1 because JavaScript finds a way to convert the 1 into the string 1, and the two strings are the same, and poof, they are suddenly the same when you might not have intended to have that. And this is why JavaScript has a triple equal. Right? In C, things are very simple, but in C++ they are not. Why? Because C++ has all those references, and it's going to pull out of its back pocket all kinds of operators when it thinks they are appropriate. And if it finds an operator equal, it will apply that and not try to resolve something at the level of reference. And when it's pointers, it's very clear, right? So the only thing you can really hang on to in C++, for example, and comes from C, is those pointers, and those pointers are precisely addresses in memory. And the pointers really make a unique identifier, at least for that specific execution of the program. Now, it's a little bit bent. It's not exactly this, especially in C. So let's see which ones are correct. If the pointer is the identifier, right? Refers to at most entity. Is that true? Let's postpone that one. Each entity is referred to by at most one identifier. This is true because everything has a memory location. So anything that exists, it's pointed to by at least one identifier. Identifier always refers to the same entity. Well, it depends on what you mean by the same entity. If you have a high-level view and you can move things in memory, then that's not true. If you have a low-level view and only if you're basically at the same physical object in memory, then that's true. So it's murky. But the first one is problematic in C, for example, because of the union types. You can actually make two virtual objects to live in the same place, and this is used by the C hackers. You can interpret the same bag of bits in two different ways, and this is exactly what the unions are. That's such a nasty programming addition that you can run in trouble in really big ways if you use unions, okay? So all of these programming languages are struggling with some sort of naming, right? Higher level programming languages, they have the naming figured out much better, but that doesn't make it less messy on portions, right? So for example, in JavaScript or in PHP, you really cannot find any, there is no notion of location in memory. There is no way for you to get anywhere close to the memory. There are some exceptions, for example, like typed arrays in which you get close enough, maybe, right? And you have to refer to things by name, right? But then you have name and context. So essentially, if you give me a context and a name, I can look up the name in the context. And essentially, the context are some sort of dictionaries, right? So then the identifier is this pair, name and context. Right? R, for example, how many people ever used R, the statistical language? R is like this, and R explicitly massages those environments. They're even called environments. Okay? It's those contexts, those environments. Right? So naming has this nasty property that every programming language has to figure out, and of course we have the corresponding thing in distributed systems. Right? So if we look at issues, for example, related to, let's say, web, because that's basically everywhere, right? How do you find a resource? How do you locate a resource? How the naming works, for example, just high level. Well, so early on a decision has been made to invent this thing called the URL, which is some sort of a naming convention, right? Now, it's not a simple naming convention. I first want to spend some time on simple naming conventions. It's more of a hierarchical naming convention. And actually, it's a very deep hierarchy, right? So let's just put this on the board, and let's keep in mind as we go along, because this is definitely one of the very sophisticated uses of naming, right? So maybe we should pull off, right, so let's name a resource that is a specific web page on the department's website, let's say. I'm going to invent half of it, but right, you get the idea. So that could be HTTP. I'm going to write the full name, right? And then I'm going to talk about cheating on naming. So it's going to be HTTP www.cise.ufl.edu / do I have a colon there? No. / and I'm continuing. That's a single line, right? So then it could be, I don't know, tilde / a dobra / index.html, let's say. Okay? So this, it's the name of a very specific web page. Or so I think. Okay? And I can talk about how things could be hijacked and might not be very specific in the end because of dynamic languages like PHP and whatnot. Okay? As a comparison, let's also take this, which is CNN.com. Okay? It turns out that both, if you go in the web browser, you do this, it's probably going to work. I hope I'm not messing something up in there. If you do this, it's going to work. They are both names. Okay? But they look very different. I mean, this looks almost unnaturally short. And it's not clear where this is going at all. I'm going to explain in a second. Okay? So why is this a complex name? Because it's made out of many, many, many parts. And all of those parts are there supposedly to help. How many people know about the short URL new wave, the new idea? Right? So they basically said is, look, whatever follows, there's nothing you can do about this except tricks. For example, what I noticed is I think there is a domain .js, right, which is some kind of country, and people started to buy the domain names in the .js because it looks so cool, right? You can have backbone.js. Yay, that's cool. Has nothing to do with whatever JS country is or whoever owns the JS domain. It just looks cool because it's JavaScript, right? Or YouTube, u2.be. That's great, right? Not that it really helps. I mean, how hard is it to say youtube.com versus u2.be? And I don't know if you know, but Google is in fact pushing for short names. They essentially say it's nonsensical. Why do I have this .com, .cic, .ufl? None of that matters. Why not flat names? Why not modify whatever this naming is to provide short names, in particular for the big things, right? So ideally, you would like to say Google / something. Why am I saying google.com or other weird decimal points in front, right? Even though it looks humanly readable, it's not necessarily easy to remember by any stretch of imagination. So naming, even though sometimes it starts small and manageable, it can become big and unmanageable nevertheless, right? And especially whatever follows in here, and especially because of other facilities that exist, naming, at least in this form, becomes less and less and less relevant, right? So how many of you really know, I mean, beyond big websites in which you have short names, how many of you remember longer URLs that are not your homepage? I mean, even remembering the class homepage for me, it takes 30 seconds. I have to burn some serious neurons to remember the class website. So it's not necessarily particularly good naming. I mean, it looks very systematic, and we have very systematic names for the class names. But you see, the trouble is I have to remember what class am I teaching, what's the decimal points of the class. So I know I'm teaching that distributed systems class. I don't remember that it's COP56, and then I'm not sure, but it's maybe 15, right? So it's a struggle. So naming that's supposed to help is not really helping that much. So what do we end up doing quite often? And I want you to understand this because no matter what you do, you're going to bump into naming. And if you bump into naming, you have to be realistic about what they achieve and what they don't achieve. So what do you really do in the end? Well, most often I find myself doing the following thing, and it's as fast as typing the URL. And the browsers help now. Because the browser bar, so Google recognized that people might not know where they go. And what they try to do is the browser tries to interpret whatever you write at the top as some sort of URL. And if it doesn't look like a URL, or if it tries to get it and it's not there, we'll pass it to Google search. And I found myself in a situation in which I don't even try to remember URLs. I just put keywords there, knowing that Google does its magic, and one of the first hits, which I'm going to recognize on the first page, is going to be what I'm looking for, right? So, for example, something I always had trouble with is finding the website of the purchasing department in UF. Until I figured out that all I need to do is put in the bar UF purchasing, and Google first hit, it's exactly what I want, right? So to a large extent, a very powerful search can actually replace naming altogether, right? And that's a powerful thing, and this is why Google is changing things. I mean, once you become synonymous with even finding things at the lowest naming level, right, that's when you win. I mean, you're part of the fabric of the internet. I mean, this is why Google is in a unique position, I believe, okay? So what's happening when you do this, when you do CNN.com? Because it's, in fact, not a complete name. So whenever you talk about naming, you're talking about convenience. Whenever you talk about convenience and naming, you have to talk about things that could be done by default that cover most of the cases that could be OK and could match what the user, in fact, refers to. And you see this all over the place in programming languages, and now you see it here on the web. And this is essentially what the users expect, right? So there are defaults that go in front. There are two defaults that will go in front here, okay? One of them, I mean, first of all, the www can be hijacked, and you have to do a little bit of magic on whatever CNN is to do it. But if not, Google will put it as a default. If it doesn't work like this, it will try www. And the HTTP in front, it's also a default. It's by far the most used type of protocol. Now, HTTPS starts to be used, but they automatically switch from HTTP to HTTPS. Nobody really remembers what's HTTP and what's HTTPS and when to use one versus the other and all that kind of stuff. Also, once you get in, you get hijacked and pushed a lot deeper. But it's actually much more than this. You see, this might not, in fact, be the name of a resource, might be the name of some abstract entity. Because Akamai, and I had a little quiz and asked you what does Akamai do. Akamai might, in fact, hijack CNN.com at your ISP and serve your local page of the CNN and not the main CNN. So CNN.com might not mean at all the servers that CNN has wherever they have servers. Might actually mean the servers that Cox has here in Gainesville, and they serve you a local version of CNN, right? So by any stretch of imagination, none of these things are, in fact, identifiers. But then what's an identifier for those things? You see, the problem is it's very tricky, and I want you to understand it's very tricky. I mean, at some point you have to give up and say, I don't even really need identifiers. I have these logical things that I'm trying to find, and I just hope that the magic works. So the problem is, a lot of this might be so-called dynamical content. It simply doesn't exist until you access it. It doesn't. It's some recipe to extract it from some sort of database that itself, it's going to change over time, right? So, for example, let's say auctions on eBay. They come and go and come and go and come and go, and eBay might reuse actually their identifiers. They do this kind of nasty thing. Why? I don't know, right? Reusing identifiers, you see, refers to the same entity, and it's kind of it's unique through the life of the universe. That's the ideal situation. Reusing identifiers is one of the biggest sources of bugs. Programming languages or accessing resources. Suddenly, at the same page, you have very different things. Missing resources when you follow identifiers, that's another very annoying thing, is the 404 errors, right? So this is why, again, on the web, you can start seeing efforts, which are different than short URLs, but they usually go hand in hand with short URLs, permanent links. So what are those permanent links? They're essentially promises that they will never use that name for any resource ever. until we change our mind. That's always kind of a, right? But more and more websites start to say, you know what, this specific thing has a life of its own, and we dedicate a permanent name for it. Now, the problem with the permanent names is if you use a nice naming technique, somebody's going to mess up, and somebody's going to reuse the nice space. If you pair it up with this ugly looking, oops, sorry about this. I should remember to turn off my phone, sorry. If you have ugly URLs, especially if you pair them up with UUIDs, then you can actually afford to have a permanent link and not to reuse the same thing again, right? So there is something subtle that goes on in here. I want you to appreciate it, okay? We're going to go through all kinds of techniques and so on, but what people thought would be okay at some point, it started to have a life of its own and shifted and became very ugly and very nasty, and then it converted into something else, right? If you think about it, the uglified URLs are about as bad as the IP addresses, right? So we go from ugly to nice to ugly again. But then you have to rely on a completely different mechanism to find the resource. And more that inevitably ends up being some sort of search, okay? So naming, it's interrelated to search, and I want you to keep this in mind as we go through various kind of materials. Because the only reason you need a name is because you want to find a resource pointed by the name. It doesn't matter that's alias, not alias, identifier, or not identifier, right? You have no reason to name anything unless you want to go back and find that resource and do something with that resource, but that's a different kind of deal, okay? But search could replace naming, right? What exactly is search? Ultimately, going from some sort of a description of properties and plus some ranking and whatnot to who has the resource. You see, if you have search, you don't really need nice names. You simply don't. I mean, who cares? Because the interface is in such a way that you want to click on something. You only care about nice structure in the names if you want to fully automate the process with some kind of scripts to do something. But if you have a search service and the search service says, oh, for this IDs, these are the resources you can access, then you shouldn't care. Now, there is something else that's much more subtle, but very important when it comes to these ugly names. Ugly names can actually achieve multiple things. One of them is you can dedicate an ugly name forever to a resource, so you never have to reuse it, okay? But there is something else. You can, in fact, significantly improve the security of a system. We're going to talk about this later, right? So you see, if the name is scrambled, and knowing the exact name of a resource is a prerequisite to find the resource, then you can make sure that the resource cannot be accessed by external entities unless they know the magic ingredients that go in the name, right? And this can be used to a great effect for security. And this is, in fact, used for various kinds of security on the web. For example, I noticed, to my surprise, it's very surprising when the large company do the right thing, right? So, for example, I noticed that, for example, on Flickr, if you have pictures or if you have albums, the actual URL is going to contain these monstrously large, very ugly-looking strings. What are those? Well, it's very easy, and we're going to talk about this when we talk about security. It's very easy to produce one of those ugly things. You take a nice name, and you push it through a cryptographically secure method, for example, a SHA-2 hashing, right? That way, you obtain an ugly thing. We know that those are extremely hard to revert, right? Now, the thing is the following. If your namespace is relatively small, you can find resources by throwing darts and by chance. And this is used to a great extent when people are trying to attack things, domains and whatnot, right? All you need to do is pick from the 4 billion IP addresses and just try your luck, right? That's not necessarily a bad thing. I mean, lots of attacks succeeded very nicely like this. You don't even have to go through the DNS. But if the space is very large, if the naming space is large and it's paired up with this uglifier, right, then in effect, you make the randomly try technique fail miserably, right? I mean, first, you can apply the following very simple techniques based on naming. And this is, I want you to understand, this is related to naming. And all programming languages will do something like this. If you're just randomly trying names, you can basically detect this mechanism and say, if you try more than 100, if you have more than 100 failures per second, I'm going to shut you off for 10 minutes, right? The same is happening when it comes to ports. Think about for example, the port numbers. You have IP addresses, which are at the low level, and then you have the port numbers. But that's naming as well. I mean, ultimately, everything is naming. Well, I would argue even the address in memory, it's some sort of naming because it's virtual. You're dealing with the virtual memory address. The physical memory address, only the operating system really knows where it is, right? So naming is part of the fabric of everything we do in computer science. It's everywhere. Higher level naming uses lower level naming, which uses lower level naming, and eventually somebody gets to some sort of bits and gets the work done, okay? But the stack is actually quite high, okay? All right, so that's basically naming for you. And for example, a lot of programming languages, they do what? They organize names into some sort of superdomains, right? So for example, C++, well, you have a notion of local variables, which are things that live on the stack. They keep on getting rewritten. But then you have things on the heap, for example. But for things on the heap, in principle, you could have a flat name hierarchy, all right? But you prefer not to. You prefer to organize it now into namespaces or something, right? You prefer to say, I want to, within this namespace, I'm going to have this kind of resource, maybe an instance of a class. And within the class, I have this member. And then the name, it's really the namespace, the name of the class or the name of the object, and then the name of the subpart. Not very dissimilar from what the URLs are all about. Okay? All right. Now, even before I go into the discussion, one very important thing is if you could reuse, I mean, first of all, naming, it's to some extent overrated because search becomes much more important. Once you buy into that, I think things become a lot more relaxed. Okay? When it comes to coming up with your own naming thing, you have to name things all the time. And you have to talk about resources all the time. If you're talking about local resources, and you're programming some programming languages that's going to impose on you some sort of naming, or you can make your own conventions how you're not going to name things. How many people here know about the Hungarian notation that Microsoft was using for a long time? And what's that Hungarian notation all about?
Prefix the name of the type of the thing that it's describing.
Right, so why do they call it Hungarian notation, and who came up with it? Well, so you see, a number of people were there at the beginning of Microsoft. And one of them, and I don't remember his name, is this Hungarian guy. And he was the heavyweight programmer on Windows at the beginning. And this is the guy that said, we are dealing with a language that's very nasty with respect to types. And by the way, in Scala, for example, types are part of the name, essentially, right? The naming and typing, and in C++, and this is what creates a mess when you go from C to C++, because types become part of the name. So in C, types are not part of the name by any stretch of imagination. So when I give you a function, there is no way for you to tell what are the inputs of that function or the outputs of that function. Right? The trouble is, there is no way for the compiler to tell. And then you can have these very subtle bugs in which you can call functions with the wrong arguments. So in order to alleviate that, the guy at Microsoft, right, came up with a set of conventions to name functions. But that produces monstruously looking names, right? So that the programmer all the time has it in his face, what does that function do, especially what it returns. The return type can be devastating if you get it wrong for a lot of the things. And C has no checks whatsoever, right? Why? Ultimately, everything is a bag of bits to these low-level languages. You can put whatever name you want on it. I don't care. I'm not going to do any checks. It's a bag of bits. So if you tell me later that the bag of bits means an integer, I'll interpret it as an integer. If you tell me that it means a float, I'll interpret it as a float. And this is how you get very strange-looking integers, right? So you go and program, especially in C, and you say, look, this is impossible. I put the number 3 here, and what I got here is this scrambled-looking thing. The compiler hates me. Well, it's the typing that's not enforced in there. So why am I saying that the typing is part of the naming in high-level programming languages? Well, again, that's one trick you can apply to simulate the Hungarian notation to enforce types. This is what C++ does. And this is why it's so hard to connect C++ with anything. Now, it's not hard for C++ to connect to anything. It's hard for anybody else to connect to C++. How many people here know about the name mingling in C++? Right, so what's that naming link?
Well, it's basically when they take, right, like the object name and the function name and like some type information, they put it all together so that when it all gets reduced down to C for the linker, it has a unique name.
Right, so C has a unique problem, and it's related to naming and the attempt to add extra information to the name to properly use it later, right? So I mean, in some sense, if I put HTTP here, I'm indicating how this should be accessed, how this should be used. So one way to really get a lot of information in any identifier and to even enforce some rules about how it should be used is to mix up in the name of the identifier information about how it should be used. In C, I'm sorry, that's information about, for example, to what class. So ultimately, OK, so you might not realize that this is true. And this is a fundamental difference, by the way, between Java and C++. On the surface, they look very similar. But deep inside, this is truly fundamental difference, right? C++ designers, so how many people know about the history of C++? Oh, by the way, I'm mentioning all of these things because it's all related to the history. It's all something that happened in the past that just makes it through. So whatever you bump into that you hate now has a point of origin somewhere. Okay? At least that knowing what the point of origin is, it might alleviate the pain you're going through now to deal with it, right? It turns out that C++ was essentially some sort of super library built on top of C. The first C++ compiler was written in the preprocessor and was translating through preprocessing techniques high-level C++-like concepts into raw C, and the raw C then compiled and pushed through. And that's still true today, essentially. Because, in fact, the low-level linker, who knows what a linker is? What does a linker do? By the way, I'm not trying to go all the way out and not even to avoid talking about what I need to talk about. One of the core issues in a linker is naming. So what does a linker do? The role of the linker is to resolve names. Okay? So that means precisely the following thing. I give you a big bundle. In the bundle, I'm going to have name to whatever actual snippets of executable code, so that if the programming counter jumps there, it's going to do something. Okay? Now, the problem is the following. You cannot fully generate the program that you're supposed to run in most modern systems, because that essentially means gather all your resources in a single shot and produce this pristine bag of bits that's fully independent of anything else in the system, maybe with the exception of system calls. Okay? That's not the way it works. The way it works now is we have many, many, many parts that need to be assembled when an executable runs. They're called libraries, right? It's the DLLs. So how many people know about the DLL hell in Windows? Now it's better, right? But about 10 years ago, it was a truly horrible problem, right? And what was the problem? Where are those DLLs that we need? What are those DLLs? Dynamically linked libraries, the SOs in Linux. So what are these dynamically linked libraries? And it all goes down eventually to how the linker works, right? So these dynamically linked libraries are these bundles that have symbolic name, again naming, to bag of bits. And essentially they contain enough information for the linking process to happen. The linking happens like this. And by the way, you can actually see it in action and you can use this. We use this, for example, in the database engine we develop. Any new code you want to run at execution time. So when you run the code, what you produce is a library. You dynamically link the library into the running program. So you add parts as the program runs, and then you call the things inside. But you see, in order for me to call the things inside, I have to know how they are called. This is what's essentially needed for the linking, right? Somebody has to know under what name the resource is mentioned in the big bag of bits, and then the low-level linker takes over, right? And the low-level linker will do the following thing. It figures out that you need a function named foo, let's say. We'll find where is it in the loaded library, and we'll replace that foo by the pointer to the function, because ultimately at the low level you only have these raw pointers, raw void pointers, right? So it's all about resolving names there, which means it's a fundamental naming problem. Because if you don't have the right name, you're not going to load the right thing. Now in C, the naming is very simple. The naming in C is flat. We're going to talk about flat names. It looks like I'm going to talk about most of them next time, which is fine. So in C, names are flat, which means the name you see is the name you get. In C, if you call a function foo, literally the name in the object produced, or the library if it's bundled in a library, or whatever. It's going to be foo, and that's it. Okay? But that's not true in C++ because of all these additions you want to put on top of it to know what the type is. Okay? In C++, and now I wish I could tell you what C++ does, but it turns out that that has never been standardized. And this is a fundamental problem with C++. Okay? So not only, and I mentioned this maybe before, but not only different compilers have a different way to produce the ugly name from the nice name. You see, in C++, this will have foo string in it, but will have a lot more stuff, right? And you can see this, by the way, if you compile a C++ program, and then you look in a library with one of the programs that dump the symbols in a library, right? You do that, you're going to see foo, and then lots of things at the beginning, foo, and lots of things at the end. Now, here's the nasty thing in C++. The nasty thing in C++, and that's because fundamentally the naming issue has not been resolved in a standard way, is not only different compilers have different way to mangle the names, but even the same compiler in a new version, right? So for example, GCC 4.7 has a different mingling technique than the 4.8. This is essentially madness. You're not even consistent with slightly older versions of yourself. Why is that the case? Because they are in a I don't care mode and recompile everything with the new compiler, right? That creates tremendous problems, for example, if you want to produce compatible compilers, right? So one issue, and that's a pure naming issue. One issue, for example, is, I don't know if you know, but the whole industry is dominated now by GCC. So we moved from a world in which the king of the road was the Visual C++. Now you have a lot of web development and whatnot that's driven by Unix systems, and in Unix systems, GCC is king. If GCC does something, everybody else has to follow. Okay? You're not compatible with GCC, you're dead. You cannot sell your compiler. Why? Vast majority of the programs are compiled with GCC, and in order for people to justify using another compiler, even if it's good, it has to be a drop-in replacement for GCC. But you see, that creates a naming problem, because you need to figure out how GCC produces those names. Because if you don't follow the same convention, you're not going to produce the same names, which means you need to figure out how to produce the identifiers. It's an identifier issue, right? If you take another program, if you don't produce the correct identifier, the linker will fail and say, but, I mean, when you have linker errors, you have extremely nasty issues to deal with. I mean, everything looks scrambled and nothing makes sense. Even if you've done this for 15 years, I mean, the thing I'm most afraid of is linking problems. Right? Compilation I can kind of deal with, but linking, it can be disastrous. You don't even know where to start. Okay? So most of the compilers, for example, will try to detect which version of GCC you have installed on the system, or have extra options to say, hey, pretend you're GCC 4.7 because it actually has different mingling than 4.8, which has vastly different mingling than 4.0, right? But it all boils down to that naming, in fact. Okay? So naming, it's a very powerful thing because it's not only some sort of something. You can carry meaning, like type information, right? In this URLs, I mean, first of all, the URL got extended to allow you to even pass parameters as part of the name, right? But because, I mean, probably most of you have not done more serious web programming, these things might not refer, in fact, to any resource, might refer to things that look more like processes, like functions, like ways to generate stuff. And some of them might, in fact, not even be resources at all, but some kind of secret ingredients there to make sure you know what you're talking about. So it looks like just a simple name, but in fact, some of this could be the password that allows you to authenticate yourself and go on and do something. Now, most of the time, that's done by other means like cookies and whatnot, but it's relatively easy to do it in the form of URLs. Okay? And the precise meaning of what something is, you have to push it through the actual execution engine. So what's now very common, for example, is to have portions, this is not the case here, but to have portions of the URL to indicate what function has to be called, for example, in PHP or whatever framework you have, and whatever follows after to be the parameters. Now, if suddenly you're talking about functions and parameters as part of the name, it's clear that whatever we think a name is very far from what, in fact, could end up being, right? So for the entire discussion about naming, we have to pay attention to these things. The hardest thing is, if you have some idea what you want, or a full idea what you want, it's how do you find it. Usually, you have some high-level names or search or whatever, and some low-level names. You're going to have the low-level one is going to be some sort of an identifier. If enough ingredients are put together, it's going to form an identifier, right? Getting from the high-level part to the low-level part, it's what resolving the name it's all about, and it could be potentially very complex exercise, including push it through search. For example, I mentioned this at the beginning of the class, right? Ultimately, once you get low level enough, you bump into TCP. And TCP imposes a certain low-level naming scheme, right? So what's the naming scheme that TCP imposes? Actually, both TCP and UDP enforce the same, because it's, in fact, enforced by IP. It's going to be IP address, and that can be IPv4 or IPv6 now. What happened to IPv5, by the way? Well, what's about to happen with IPv6, namely it became irrelevant, and they found a better one, but it's still not fully deployed. Okay. IP, right? So the IP is basically just a fancy way to represent a 32-bit number or a 128-bit number for IPv6. And then what? The port number. So the port number is part of the low-level naming of IP. Right? Now, we know at least that we can rely on that because it's remained unchanged if you talk about IPv4 and ports for 30 years. That's the more stable part of the entire system. Everything else could change tomorrow, okay, literally. If Google gets it their way, and they just say, actually, Google already got it their way, let me point out. How? You see, DNS is only a standard and can only control things if it's used. Google started more and more not to use it, at least not in the way the DNS people hope, right? So I just want to point out that's how interesting things are getting, right? Because Google Chrome has 40-something% of the market in terms of browsers. They, in fact, make the rules. Microsoft tried this before, and it ended up in a disaster, right? We'll see if Google exercise ends up in a disaster or not. But in effect, Google now allows you to access resources without really going through DNS servers. Okay? Now, you ultimately kind of go through DNS servers because they don't want to bother to resolve everything. But they could, in fact, resolve everything and go down to IP addresses. And, in fact, bypass completely any attempt to do DNSs in that way, at least for the normal web browsing. Okay? Still, the DNSs are important because most other applications won't go necessarily through Google. But if you go through Google, they could get you down they could get you all the way down. Why? Because there is a convention that essentially says that if you put here an IP address, that can be recognized, and then there is no need to go through a DNS. You can go at the lowest level for an IP address. Right? That's something that the browsers do. The browsers will try to identify whether the name here is a high-level name or a low-level name. And if it's a low-level name, it will not go through DNSs. Okay? And we'll just resolve it at the lowest level. Right? Good. So, well, I better not talk about this. I wanted to say something else important here, but somehow. Right, so let's think about some other instances with the naming, and then we are going to see the more formal treatment next time, right? So, for example, imagine other things, this peer-to-peer systems, right? So, very high level, what are various ways to find something? So to find something really means I give you something that might or might not look like a name, or enough of that for you to come up at least with alternatives. And you're supposed to find me resources. Search comes to mind, but let's say I give you, in fact, something that looks like a name. You must have some sort of a naming service. And this is what the discussion next time is going to be. It's how those naming services look like. What do they do? How could they work? I mean, if you are born with an iPad in your hands, things just work, right? I mean, the internet just exists. It just works. Why question anything? It works, right? Well, we are engineers, and you're going to be in a position where you have your own opportunity to create things that in the long run will mess up many things. So this is why I'm telling you it's how to think about it and how to decide what's important and what's not important, right? So if you start digging inside in how this naming works, you have to ask questions related to how can I provide an efficient mechanism that maps names so that, I mean, why does it have to be efficient? So a naming mechanism has to find a good answer right? If it's search, then it's very important to have a good definition of what good answer means. If it truly it's an identifier for a name, that means, well, not map it in the wrong way, right? But it also has to be efficient. Well, you see, efficiency is something that none of you care about until it's missing, right? So if you have a really bad naming, I mean, not a really bad, a really slow naming technique, it doesn't matter how fast the internet is. You can actually take down the whole internet by killing naming services. At the IP level, everything works, just nobody knows how to find the right IP. Also, by the way, that can be used as a mechanism to create a so-called dark internet. Anybody knows about what dark internet refers to? It's parts of the internet that are not mapped by the search engines, and they don't have nice names corresponding to DNSs. You see, in fact, you have no strict requirement to obtain a domain name to have a nice name. Who says you should have a nice name? And for example, hackers, most of the time, they don't use a nice name. They don't never register a domain. They just memorize IP addresses, right? Or they have their own super secret, cryptographically secure naming servers in which if you don't log in the right way, I'm not going to tell you what IP corresponds to what high-level name, right? And who says you should use DNS for naming? No, you can use anything you want. In fact, you can decide which DNS server to use. For example, by the way, even if you sign up with, say, Cox for cable, you can put your own DNS, and there is a large project called OpenDNS, which means any DNS request goes to OpenDNS servers, not to the Cox servers. By the way, Cox really likes to mess with the domain name. Not Cox, but in general, the ISPs are known to even inject in traffic all kinds of things and so on. For example, advertising in traffic, they experimented with things like this, right? And the only way they can do that is when they notice, when you go through their DNS server, what resource you want to get. If you're going straight on an IP address, reverse IP lookups are possible, but much more difficult because it's not something that normally happens and it's not an efficient mechanism. So it's very hard for Cox to say, oh, you're going to this IP. I know you're going to CNN. Not to mention it's very, very complex. Akamai intercepts and does things and whatnot. But if you go to CNN.com and they see that, they say, I know that I need to put some stuff in your traffic or to do things, right? So ultimately, a lot hangs on this idea that naming works in a certain way, can be hijacked in a certain way, and a lot can be circumvented by essentially using other name servers. And hackers have a completely different naming, right? So that's DNS. What about some peer-to-peer networks? We're going to talk about them. In peer-to-peer networks, naming is one of the major issues. Once you know that somebody has a resource, you can form a TCP/IP connection and just get the resource. But peer-to-peer networks are only about naming. Nothing else matters because everything else can be resolved mostly by direct connections. Okay? And it is resolved by direct connections. You have no reason to form a chain of TCP/IP connections unless you're trying to hack into a system and you're trying to hide your trail, maybe. But other than that, a direct connection, if you found the low-level address, the low-level name of a resource, IP address and port number, that's the only thing that matters. The rest is parameters that are passed to the program that listens at the end of the port, right? So the moment you resolve that, you solve the problem. So we're going to see peer-to-peer networks. And essentially, the discussion is going to be about naming, about how do you find things in a peer-to-peer network. One specific way to find things, which is not necessarily bad until the network becomes large, is to simply shout and say, who has this resource? It's called broadcasting. It sounds dumb, but arguably at the lowest level you have to do this. I'm going to come back to this next time. You see, everything is nice and dandy once you have an infrastructure put up, but to even put infrastructure up, you have to do some shouting. Okay? And for example, when my phone wants to connect to the internet, has to shout, hey, is anybody there listening and they could give me direct access? Once they found somebody, they can try to run some protocol that allows some kind of an internet connection to be established. But some shouting is needed, at least at the lower level. And we're going to talk about that. Is the ARP protocol in the Ethernet and the similar protocol for the wireless network. But you could shout on much larger networks. And for example, a lot of peer-to-peer systems work like this, right? You essentially start sending this message that gets broadcasted, or maybe some limited broadcast. It's to say, hey, anybody has this movie because I want to download it or whatever, right? That has a magic advantage. You can, in fact, do some form of powerful search then, and it's not really just naming, right? For example, you can resolve partial names. You can try to do approximate matches and whatnot, which are virtually impossible to do in DNS, by the way it's structured. So when you have performance, usually you give up on other things. For example, do I have a relaxed naming scheme or not? Right? All right. All of that is going to come next time. So think about this naming a little bit. Of course, work on the project you have to work on. Right? Just remember the naming is absolutely everywhere, and you have to seriously patch everything together when you decide how to name things, because that can have extremely long repercussions on how things work. Something that looks good now could be a complete disaster 5 years down the road if people really start to use it. Okay? So I'll see you. Okay, so for the quiz, naming is going to be some kind of high-level fluffy questions, maybe one question. The rest of it is going to be about the communication again. Okay? So I'm going to have a quiz, 4 questions, same format. About 3 questions about communication and 1 high-level question about naming. It's things like which one does not characterize naming? I like the not questions, because that forces you to really read my questions and my sentences. All right? So I'll see you all Tuesday.